Welcome to Pure 1, Chapter 11.5, where we look into vectors and solving geometric problems. Sorry, do I sound too robotic? Anyway, right. I'm sure after this lesson we'll be good friends because we'll be going through some mind wrecking, socks blowing, and some life changing, maybe not life changing, questions where actually they could be proven quite difficult in terms of vectors. So let's have a look. When a vector is parallel to another one, we can express it as a multiple of each other. Okay, so for example, if AB is parallel to CD, and given that AB is a vector A, then we can say CD equals to lambda of A. We've used lambda or mu, or we can use mu A. These two Greek letters are what we tend to use for vectors in terms of multiples. Okay, where lambda or mu is a constant. E.g., for example, constant. For example, if you say CD is half length of AB, then the lambda and mu value will be half. If you say CD is 3 times longer than AB, which is parallel, then you say 3A, then lambda and mu will be 3. Okay? So, right, example, practice question 1. The points AB, these are something quite similar to GCSE. You can think of those are really, really difficult questions in GCSE. Actually, they could be A-level questions. So if you are confident, you can have a go. Actually, I don't stop you. That's why I put a practice question 1. So if you're interested, the points A, B are position vector, A and B respectively. So we talk about position vector means OA and AB, which is actually denoted on the diagram. Remember, position vector 11.4, we talk about position vector of A means OA. All right, as shown in diagram, the point P divides AB into ratio of 1 to 2. So that means as a whole line, we're out of 3. Right? Find the position vector of P. Find the position vector of P. That means we'll find OP. All right, not overpowered, OP. So OP, we want to make a root from O to P. Well, simple. OP is OA plus AP. So OA is A, but AP is unknown. So what's AP? Well, we know AP could be written as a third of AB. Now, it has to be AB, not BA, because AP is in direction of AB. AP is in the direction of AB, right? So what's AB? Well, on a side note, to work out AB, AB is same as AO plus OB. So AO is negative A, OB is B. So we can sub in here, right? So equals to A plus a third of minus A plus B. Expand the bracket. So equals to A minus a third A plus a third B. You can put this in the calculator. It simply is 1A minus a third A. 1 minus a third is the same as 2/3 of A plus 1/3 of B. Easy peasy, OP squeezy. Right, next one. Okay, example 1 star, because there will be a 2 star and there will be 3 stars. I think that's where we start to become friends. Now we're still acquaintance. Right, example, a star. Given that OABC, okay, OABC, if you don't know drawing diagram, it must be the letter must be going in clockwise direction. Okay, so if O is here, then A must be here. Well, actually, I don't know why I draw it like this. Sorry, maybe it was my mistake. But in a diagram exam question, usually you don't have to draw your own one. So given OABC is a parallelogram, where X is a point on AB such that AX to XB is 3 to 1. M is the midpoint of BC. Show that XM is parallel to OC. To show they're parallel, we just have to find each of them. So XM, let's do XM. Okay, so XM. To go from X to M, quite tricky. I think the closest way, if I rub up all the blue marks in here, it'll be easy to see. It'll be XB plus BM. I think that's the easiest one to do. Okay. But XB and BM, none of them are given to you, obviously. So we do have to do a bit of investigation. So XB, we know AX to XB is 3 to 1. That means XB is a quarter of, now XB is going that way, of AB. Okay, hopefully you see this. I think that's why people do find vector proof a bit difficult in general. So a quarter of AB. And BM that way, BM, because it's cut in half, so a half of BC. So our next goal is to work with AB and BC. So AB. So AB equals to AO plus OB. Finally, something we can use the question. AO is negative A. OB is B. BC, what BC? BC, because it's parallelogram. So BC is the same as OA, parallelogram, because of, you can write down here, is you don't have to explain in lesson, no, in exam, sorry, but you do just to make you aware. Okay, in notes, you understand this parallelogram. So BC equals OA, which equals to A. So now if we go back to the blue line, so therefore XM. Oh, do you see how I actually draw the two eyes, the X crossing all the, using all the eyes, on my logo? XM equals XB. So XB is a quarter of AB, a quarter of minus A plus B, these eyes. And plus BM plus a half of BC, which is A. So expand the bracket, negative a quarter A plus a quarter B plus a half A. Put in a calculator, minus a quarter plus a half. Let me double check the minus quarter plus a half is indeed a quarter A plus a quarter B. So we found XM. Next, let's find OC. So OC equals to OA plus AC. So OA is A, AC is the same as OB, so which is B. So now if you look at these two in here, they actually are parallel because XM you could easily factorize a quarter. So therefore, so final line, okay? So because XM equals a quarter of OC, because they both equals A plus B, so that A plus B is OC. Therefore, XM is parallel to OC. You just have to show that they have the same vector. Now, a quarter of A plus a quarter B is not good enough. You do have to factorize a quarter out. Okay, factorize the constant out. All right, acquaintance. Next, we become a slightly good friend. Okay, better friend. Okay, maybe we're not BFF yet, but we are here. We're good friends. Right, example, 2 stars. Okay, crank up a notch of pain. OAB is a triangle. I'll let you read the question, or maybe if you have a different paper, you can have a go at the question. There are more than one ways to do it, by the way. Okay, so I'll let you pause the video if you want to and have a go. All right, and you can come back to me and cry on my shoulder. So example, OAB is a triangle. OA is A. All right, OB is B. Nice. M divides OA in 3 to 2. That means fraction out of 5. Given MN, so they tell you MN, which is not on the diagram, so you might want to draw a line, okay? You do want to draw a line. MN is parallel to OB. So express the vector ON in terms of A and B. Now remember, I mentioned in the notes, when you are told MN is parallel to OB, so because, so we can say MN equals to lambda of B. Because MN is parallel to OB. Therefore, lambda we can use a constant. Okay, so let's do this. So ON, we know ON, right? So ON equals OM plus MN. OM is 3/5 of A because OA is A, so OM is 3/5 of it, plus MN plus lambda B. Now, this is not good enough. We can't finish this. We can't leave it like this because we have lambda in there, so we cannot leave it like this. But we don't have enough information to work out lambda either. So what can we do? So this is a trick. So we need, I use different color to show you the steps in here. We need to find lambda. So we're going to rewrite ON in a different way. Okay. Right, so that's the tricky part, okay, to find ON a different way. So let's do it again. So ON, how can we write differently? Maybe we can do OA plus AN. Or we can do OB plus BN, which is fine, right? So what's OA? Well, OA is A. What about AN? Now, we don't know anything about AN, do we? We actually don't. So what we know is AN is part of AB. So that another tricky part. So AN is part of AB. Part of means a fraction of it. So we can say, so we can let AN equals mu of AB. So AN is part of AB. If AN is half of AB, then AN will be half AB, right? AN is part of AB. We're doing a ratio. So AN will be mu AB. We can't use lambda because we've used lambda already. So we can now go back in here. So we can say AN plus mu AB. But what's AB? Good question. AB is the same as AO plus OB. So if you're struggling with to follow it, what you can do is you can color code it so you know this is where it come from. Okay. Next, and the left hand side is ON. So expand bracket, so ON equals to A plus mu of AO, which is negative A, OB is B. Expand bracket, A minus mu A plus mu B. That's ON. Okay. So next step. Now we now have two ON expressions. ON equals 3/5 of A plus lambda B. ON also equals to A minus mu A plus mu B. What I'll do in here is I'll factorize the A because A is a vector. So what I'll do is I'll put 1 minus mu of A plus mu B. Now, we must put A at the back. We can't put it in the front even though we're factorizing A because A is a vector. Okay, so I and J, what you've learned before, you put 3I plus 4J. You don't write I3 plus 4 plus J4, right? You always put I and J at the back. Same with A and B. So now, the next step. Because both are ON, what we can do is we can make them equal. Okay, we can make them equal. So 3/5 of A plus lambda B equals to 1 minus mu A plus mu B. ON, ON, they're equal. Next step, we're going to compare coefficient. We're going to compare coefficients of A and B separately. If you haven't cried yet, hold it. Good job, well done so far. If you're crying, you got tissues next to you. Okay, keep crying because you're not going to have any tears in the exam if you see this. um, right, so let's compare A. Okay, so let's compare A. So we have 3/5 on the left hand side equals 1 minus mu. Okay, and if you try to simplify it, bring the mu left hand side and bring the 3/5 to the right hand side. Mu equals to 2/5. And B, if you compare the coefficients of B, lambda equals to mu. So now lambda, we know is also 2/5. Okay. So what do we know about mu and lambda? So once we found mu and lambda, we can now finally rewrite ON, can't we? So now finally, ON equals to 3/5 of A plus lambda B plus 2/5 of B. Ta-da! Yes, quite difficult. This question easy worth 6 marks, I think. 5, 6 marks. Okay. Right. Part B, show that AN to NB is 2 to 3. We have actually done a lot of work in part A already. So show that part B, AN to AN is 2 to 3. So let me copy this diagram question. And can I drag it down there? Come on. Right. I know you don't want to move it, but you have to move it. Move it. Right. So AN to NB. So what do we know about? So part B. So we know AN, okay, is mu of AB, right? From part A, somewhere steps. And we know mu is 2/5. So we know AN equals 2/5 of AB because the value of mu from there. And if AN is 2/5 of AB, now think about this. AN is 2/5 of AB. That means the whole length is broken into 5 parts, and AN is 2 parts of it. So therefore, NB is 3/5 of AB, Now, if it takes you time to reread the whole thing, do it. Play it again, step by step, and try to learn each step. What am I doing? Okay. So because AN is 2/5 of AB, therefore NB is three parts. And therefore AN to NB is 2 to 3. Okay. The hardest part lies on the part A. I'll explain again. This happens quite often when it comes to vector proof, where you have just lambda and mu. Okay, express ON vector in terms of A and B. So I know MN is parallel to OB, therefore I let MN equals to lambda B. If I want to find ON, I find a journey from O to N, find the root. I easily O to M, N to N, M to N. OM is 3/5 of A, that's basic vector. MN is lambda B. But we need to find lambda. So we use we rewrite ON a different way, different route. So we can now go ON equals OA plus AN. You can also go OB plus BN, which if you're interested, you can use different paper to try it, which makes exactly the same. Apart from the fact that you will find, I think you will find mu as 3/5 instead of 2/5. Anyway, so ON equals OA plus AN. OA, which is A, plus AN. Let me use different color. OA is A. AN. AN is part of AB, which we don't have the ratio in here. That's the thing is we don't have the ratio. We don't have ratio. Therefore, we cannot let it to be half. We can let it doesn't tell us 3 to 2. Okay, we cannot assume it's 3 to 2 or 2 to 3, etc. So we don't know. So we say AN is a mu of AB, a part of a fraction of AB. So then we go into AB. So what's AB? AB is AO plus OB minus A plus B. Expand bracket. Okay, expand bracket. And then when you see more than one A, factorize it and group them up. So 1 minus mu, factorize A, 1 minus mu plus mu B. Next, once you found two ways of rewriting ON, make them equal, left and right. Don't simplify it, just compare coefficients. Compare the coefficient of A, 3/5, compared to 1 minus A. Make them equal, solve it, then mu equals to 2/5. Compare coefficient of B, lambda and mu. Lambda equals mu, so lambda also equals 2/5. Then you look at where the question again, you want to work out ON. So where's ON? ON is here. So ON equals 3/5 of A plus lambda B, and that's the answer. Alternatively, you can sub in here 1 minus mu, 1 minus 2/5, 3/5 of A plus, again, 2/5 of B, same thing. All right. Part B, to show ON to NB is 2 to 3, we now know AN is mu of AB. Mu is 2/5. So AN is 2/5 of AB. Therefore, the whole line is broken in two parts. If this 2 parts and the whole thing is 5, we definitely know this 3. That's what I'm trying to do. Okay? Right. Are we good friends yet? Yes? Time to level up our friendship to become a BFF. Example, 3 stars, like a Michelin. OACB. OACB, as I said, is what it goes clockwise. Okay. Is a parallelogram. Maybe nice, maybe not. OA is A. OB is B. The diagonals of OC and AB intersect at point X. Prove the diagonals bisect each other. Bisect means cut each other in half. Like what we do to siblings. Just kidding, we don't. Not in real life. So maybe in dreams, maybe. Prove that the diagonals bisect each other. When we say bisect each other, means cut into half. That means, okay, so this is what they want you to do. Okay, that means they want you, so want to prove, so want to prove OX is a half of OC and AX is a half of AB. Now, think about this, okay? Any question about this? If you do, don't tell me because I can't hear it. That's what they want. That's what they want you to prove. Bisect means that's what they want you to prove. But obviously, we don't know if it's a half, even though we know we have to prove a half. So this is our sign line. Okay, so we're going to let OX equals to lambda of OC, and we let AX equals to mu of AB. Okay, and what do we know about lambda and mu at the end? If you do correctly, they will equal to half. Right? So first step, we're going to let that. Okay. You might do the similar question in the Prex book or exercise or textbook exercise. A lot of them, especially this one here. You might have some tricky ones. When you do this, when you're unsure about the ratio, then you do this trick. So OX now proof diagonal. Okay. Second step. So why don't we make it a bit longer? So why don't we just rewrite OX in? So OX, what's OC? So OX equals lambda of OC. So OC is OB plus BC, which is same as lambda of, now keep writing left hand side. I know some people will be lazy like I did in the previous question. I didn't write left hand side, but you should keep writing left hand side of OB. So OB is B, BC is parallel to OA, so B plus A. Okay, I'm going to expand the bracket. Lambda B plus lambda A. Also, I need to do the same for AX. So AX is same as mu of AB. So what's AB? AB is AO plus OB, or AC plus CB, whichever way. So AX equals to mu of AO, which is negative A plus B. Expand bracket, negative mu A plus mu B. Again, we keep the A and B at the back of each term. Okay, you don't write A mu A. It has to be mu A, right? Because A is a vector. So that's step 2. Step 3, that's the trickiest part. Okay, now you see we've got 2 equations here. Unlike the previous one, we write ON differently. This time, we are going to rewrite OX in such that AX is involved. So we don't want to rewrite OX such that AX is involved. How? Well, OX, we could write OX equals OA plus AX. That's the only way. Or, well, if you really want to, you can go OB plus BC plus CA plus AX. But we need the AX involved. So OX equals to OA plus AX. Now, this is where we can use our previous equation. So OX, if I use a color coded, so this OX, we can sub in here. Okay, different color, yellow. And this AX, guess where we can sub it in? Yes, you got it right, Dora the Explorer. So that's what we did. So OX. So OX is lambda B plus lambda A. Let me use color again. What is it? So that's the OX. Oops, what happened? Highlights up. That's OX. Equals OA. So what's OA again? OA is just A. So A plus AX. AX is minus mu A plus mu B. Highlights up. Go away. That's AX. What should we do on the right hand side? Well, we see the 2 A's in here. So as usual, now do not try and mix them around. Okay. Left and right, keep a social distancing. Shouldn't cross it equal. So A minus mu A, expand bracket, plus and plus still makes a plus. Then we see 2 A's. We want to group them up. Okay. So group them up. 1 minus mu A plus mu B. Group them up means factorize it. 4th step, compare coefficient like the previous one. Okay. Compare coefficient. So compare coefficients of A and B separately. Okay, so let's compare coefficients of A. So if we compare coefficient of A left hand side, we've got lambda on the right side with 1 minus mu. For B, we have lambda on left hand side, and the right side we've got mu. Interestingly, we got the same workout like last time. But what's different is this time, if lambda equals mu, simultaneous equation. Okay, so lambda equals 1 minus lambda. And bring lambda over, 2 lambda equals 1. Lambda equals a half. We know it is correct. Yay, high five. Right, lambda equals a half. Therefore, mu also equals a half. Therefore, OX is indeed a half of OC, and AX is indeed a half of AB. Proven! Yay! I can officially announce that we're now BFF until the video finished. Right, so have a go. Pause the video. Now, this similar question to the one just now in here. Okay, if you need help, do refer back to this working out. Okay, but I try to guide you in part A and part B. So part A and part B is, I think, step 1 and step 2. Pause the video, have a go. Part A and part B first. When you're done with part A and part B, then you can press play. So here's the answer for A and B. Okay, so I deliberately color coded for you. Now there are more than one way to do it. Okay, but your final answer should always be the same. So my way of doing it is mn equals to m to b, m to o, sorry, m to b, m to o. That's actually ideal. The other time I did it was m to b, b to c. Anyway, this time I did m to o to a to n. Mo now is opposite to the arrow, so it will be negative b. So it's 1/5 of b because 1 to 4 divided by 1 to 4. So as the fraction would be out of 5. So 1/5 of negative b because opposite direction plus OA, which is A. So you can see I use green to show you this corresponds to OA. And AN, which is 4/5 of B. So minus 1/5 plus 4/5 of B is 3/5 of B plus A. For ST, I did S to C, C to A to T. SC is 4/5 of A, and C to A is negative B because opposite to the arrow. And then opposite the arrow is 1/5 of negative A. So simplify, you get 3/5 of A minus B. Okay, hopefully you don't have any issue with that. Part C, now this is where you should follow the steps. Step one, actually step two has been done for you. You can use the answer for step in part A and B. This is step two. Okay, and try reread part three, question step three, and try redo step four. Okay, so if you struggle with it, you either get it right or wrong. We know part C, the answer will have to be a half, lambda mu as a half. So I'm going to show you the beginning, okay, and then just start you off. So part C, to show that bisect each other, you want to show MD, which is D is the midpoint, is lambda of MN, step one, and also SD is mu of ST, the whole line. Okay, so that's what you should get, and you should get lambda mu equals a half. So pause video, have a go now, okay? When you're ready for the step by step, I think once you finish this, that's the end of lesson, right? Yes. Then we officially become BFF after this. Actually, we are BFF squared after finish this video. Okay, no one can break us apart. So have a go, okay? When you're done, then well done. That's the end of the lesson for you. Okay, but if you don't, I'm gonna go through with you. Okay, pause video now, have a go. When you're ready, you can press play. Okay, right. That's step one. Okay, so I'm going to write MD. So step one, so MD, so MD. Yep, so step two. So MD equals to lambda of MN, which is what we've got, 3/5 of B plus A. This is what we got from part A. I'm going to expand the bracket, so MD equals to 3/5 of lambda B plus lambda A. Also, I know that SD equals to mu of ST, which is 3/5 of A plus B. So expand the bracket, it'll be 3/5 of mu A plus mu B. Okay, so after that, what's next? I've got MD, I've got SD. Third step, I need to rewrite MD but include SD. So how to do that? I need to include SD. I need to go through this route. So I must go through MB and then your favorite BS and then SD. Okay, so MD, we know MD in here, which is 3/5 of lambda B plus lambda A. We can rewrite the left hand side equals. Again, pause the video, feel free at any point you find confident to continue from there, go ahead. MB, so MB is 4/5 of B plus BS. BS is a fifth of A, and SD, which is 3/5 of mu A plus mu B. So let me highlight it. So MB, MB. What else? What color can I use? BS. Oops. Highlighter. BS, BS. What color can I use? Orange. SD, SD. Okay. So next on the, I'm not going to mango anything. I'm going to keep the left hand side the same. But on the right hand side, I can see some B's and A. I'm going to factorize A's first. So in the A's, I've got 1/5 plus 3/5 mu of A. For B, it's 4/5 plus mu B. Step four, compare coefficient. Right, compare coefficient. For A, on the left hand side, I've got lambda. On the right hand side, I've got 1/5 plus 3/5 mu. B, I can do 3/5 of lambda equals 4/5 plus mu. Okay. Now, if you don't know, this is simultaneous equation looks complicated, but this is a linear simultaneous equation. You can actually use a calculator to solve it for you. Let me show you. So if you have a similar calculator, able calculator, go on menu. Okay, you should go to equation, a function, and then simultaneous equation. Unknowns two. Now, but what you need to do is you need to bring the lambda mu on the left side and the constant term on the right side. So you can see lambda, if lambda is our x, it'll be 1. And if you bring the 3/5 over to the left, it'll be negative 3/5. So minus 3, oops, negative 3/5. Okay. And then right hand side is the constant 1/5. Second equation is 3/5 for the x. Bring the mu to left side becomes minus 1. And then constant term is 4/5. And then before you press equal, pray, finger cross, get a four-leaf clover equal. X is not the answer. So there must be something wrong. Uh-oh. Okay, I actually found my mistake. It's a minus. There should be. Okay, that's such a silly mistake, and it ruins the whole thing. So that should be a minus, and then that should be a minus. That should be a minus, and that should be a minus. So I'm gonna fix it. Okay, that's okay. We make mistake. We all make mistake. So do I. So I'm gonna put a just to show you. I'm gonna use red color to show all my mistake. And here should be a minus. 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 Okay, so let's try again. Put in a calculator. So this time, maybe what I'll do is I'll break all the constant or the variable on the left hand side. Okay, finger crossed. Let's try again. So let's try again. 1 and then minus 3/5. The first equation is fine. Second one, where this should be a plus 1. Okay, finger crossed again. Yes, yes, yes. So lambda equals a half, and y mu also equals a half. Yes. Therefore, md is a half of mn, and SD is a half of ST. Therefore, MN bisects ST. We got there. Finally. All right. That's it. No goodbyes. Nothing. Bye.